In example 1, say we want to solve for output voltage and output current given our source voltage is equal to 10 volts and our load resistance is equal to 20 kiloohms. In our circuit below, we have an operational amplifier where we have a voltage source connected to a serial resistor that is connected to our non-inverting input terminal. And then at our output, we have our output terminal connected to a load resistor that is then connected to ground. For us to analyze the system, we will start by listing the assumptions associated with an ideal operational amplifier. That is, V1 is going to be equal to V2, and our input currents I1 and I2 are going to identically be equal to 0. For us to begin, we want to construct a KCL equation that relates our input and output. That is, we would choose our output node where we can relate our input current I1, our output current I0, and our current running through our load resistor IL. In doing such, looking at our output terminal, we'd recognize we'd have I1 exiting, we'd have I out exiting, and we'd have I sub L exiting. Implying our assumption for an ideal operational amplifier, I1 is going to be equal to 0. Now, from the assumptions of our ideal operational amplifier, we know that V1 is equal to V2, where V1 is going to be equal to our output voltage. Now V2 is going to be equal to our source voltage, for I2 runs through RS, and since I2 is equal to 0, there is no voltage potential across RS. That is, V2 is equal to Vs. Therefore, going back to our KCL equation, we can say our output current is equal to minus I sub L, where I sub L would be our output voltage less ground per our load resistance, where our output voltage is equal to V1, which is equal to V2, which is equal to Vs, such that our output current can be expressed as minus Vs per RL, which is equal to minus 10 volts per 20 kiloohms, or minus 0.5 milliamps.